All right, how is everybody feeling about where we're at? Decent? I'm not going to complain about decent.
Scared.
Scared? Why scared?
It's just a lot of information. I don't know. I was kind of saying last time that it's just the language is so different. So it's just
Very true. That is very true.
I think the more classes that will go on, I think, at least for me, I'll be able to understand a little bit better because I'll see you just use it naturally, like what we've learned.
That's
and then
true.
I'll, like, catch on to
That's
what
true.
they do as it goes. So.
Okay. Yeah, that's good. Anybody else? All right, so today I'm hoping we can get through a couple of things. The main focus I wanted to talk about today was arrays or slices. But as I was working on a blog post for it, I kind of realized that unless you understand why an array or a slice is important, it's kind of hard to explain using one. So today we're going to start out where we left off. And if you remember, we had this fire function, right? So we had our ship and we have our update method, and part of that update cycle is going to be to try to fire something. Makes me wonder whose alarm is going off.
Your car.
Oh, good, it stopped. I was like, am I going to have to go around there and check and see if that's me? So what we're going to do is we're going to talk about kind of the nature in Go that functions are first-class citizens. And we're going to use that idea to be able to get the game to handle kind of the logic of firing for us as we want to fire a depth charge. And then from there, we'll actually try to build out a depth charge and show how we can have multiple depth charges at one time. I think that's probably about what we're going to get through today. So I guess we can just jump right in. So if we remember, did you guys get to watch the video about running the actual code from your development environment instead of the command line? No, it's fine. I'm just curious. So, you know, we have been using the command line quite a lot.
Was there anything else you had to install? I remember when I tried to run it, it just didn't run from my...
Just as far as like VS Code goes?
Yeah, I don't know. Like, I feel like it was complaining about the debugger. I didn't like, it was only like a...
That's... So, truth be told, I'm actually more of an IntelliJ user. And I've kind of been mixing it up a little bit for this class to try to get familiar, because VS Code is the free option and IntelliJ is not. Did you come here and install this extension? The Go extension? I really think that's all that's required now, is to install the Go extension.
Yeah, it says the DLV command is not available.
Oh, delve. Okay.
Oh, okay. It actually tells me how to fix it.
So yeah, I'm sorry. I've already have. So it's called delve, and it's the debugger for Go. I completely spaced mentioning that, and yeah, and in the warnings it should tell you.
I think I clicked on it. It says like click to install, but it doesn't actually install for some reason. So I have to probably just run the command again.
Yeah. So if that's the case, you're looking for like to search for Go delve. And there'll be a command that will tell you how to install. I don't know what the path is, but it'll be like go install github.com/something/delve. And then it will put it in your Go bin. And hopefully Visual Studio Code will find it. Does everybody know what I mean when I say like put it in your Go bin? So you've got like a directory, and Go looks at a certain place for libraries and for binaries, and binaries are compiled code. It's kind of along the line of doing like a pip install if you do that in Python, and then Python will set it up to know where to look for it.
It's not a per project install, it's for the global.
Yeah, it'll be a global tool that you'll have. All right, so if I run this, and if we remember, we can drive our submarine, and then if we hit spacebar, we'll call fire. But right now, the fire is happening inside of our ship struct, inside of our ship object, and we want it inside of the game struct. More so maybe personal preference, but we want the game struct to be able to manage all of the objects within our game, and we don't necessarily want the ship to know about everything. Does that make sense to you guys?
I want to do collision detection later, or is it?
Well, it has to do with collision detection, but it also has to do with one of those fun programming ideas called coupling and cohesion. So we don't want our ship struct to do more than it needs to, if that makes sense. And so what we're going to do is we'll create a depth charge struct that will control and manage how a depth charge works. And yes, as you say with collision, if it's inside of the game, then we can run our collision detection with all of our game objects. And so we'll kind of let the game manage the coupling of the different components for us, rather than the components knowing about everything else. So that'll make it easier for us to update our individual structs and put features in there. So let's create a function on our game, or a method, and what would you guys like to call it? Something that will have a firing of a depth charge happen. Naming's the hardest part. Charge? How about we be just a little bit more specific? So we'll like request a charge, okay? And over here, inside of our ship struct, so we have this new ship method that we created, and we're going to pass an argument to this new ship, and we'll just name it the same thing. And it's going to be of type function with no parameters and no return. And then we can also add a same named property on our struct. And then when we create,
You're gonna need to put a G in that. Remind something.
yeah, I definitely spelled it wrong, didn't I? Request. And that's what they tell you. It's really tough programming live. Is that better? Does that look better? Okay, so we have this request charge, and now, because we have a new parameter to our new ship, we'll actually see that we're getting a compiler error. Not enough arguments in call to new ship. But we're going to have just a little bit of a problem, because we've got our game and we've defined this request charge. But if we look down at our new ship call, we actually don't have a game, an object to our game or reference to our game yet. So we can do a couple different things. we don't actually have to set the ship at this point. We can just initialize an empty game, and then we can set our properties on it, and then we can have our sub game, and we can pass this method on our game into our ship when we create it. And now we'll actually have access to that method inside of our ship. So there still is some coupling going on, but it's loose coupling because it's just a function that we're being used, and it's just going to be used as a callback. So we can come here to our request charge. And we can take our log statement out there, and we can put it in over here. Make sure that we have this imported. Oh, actually, it's right here. So we'll import our log, and then we can do s.requestCharge. And if you notice, let's actually come look here. When we're passing this request charge, we don't have any parens on that, so it's actually passing a reference of the function. And then when we call it, we're actually using the parens over on this other side. So it's actually calling that first class function that we've passed around. So if we did everything right, we should be able to run our game and still get the same. Oh, let's see, we didn't do everything right. We have to remove this import. So if we run our game, main.go. I thought I imported it and it says it didn't. Oh, it's right there. Maybe not. Yeah, that was it. Okay, so we've got our game here. So if we hit our space bar, we're getting fire requested, but now the game knows about the fire being requested instead of just our ship. So we're communicating back into the game and say, okay, we want to fire something, but now what do we have to fire? We don't, yeah, the depth charge, but we don't have a depth charge, right? So we need to create one. All right, so we will I'm gonna have to shift just a little bit. I think my neck's gonna get a weird cricket sitting here looking at it the way that I am. All right, so what do we know about our ship that we might have something in common with the depth charge? No, go for it.
The depth charge is good. You fire from where your ship is.
So we're gonna go. I'm gonna actually put this over here. And this is part of one of the reasons why we've called back into the game. Chip, sorry. It's a weird Portuguese thing I've never been able to break the habit of. So we have a depth charge, and we know we need to fire it from where the ship is, but what does that mean we need to know? Does the depth charge itself need to know? So if the game knows where the ship is, we're going to have to keep some sort of location for the depth charge, right? So we can have an X, we can have a Y. What else might we need to know about an object in our 2D space that is common with our ship? Dimensions? Yes, dimensions. I'm going to actually do something a little different. Yep, dimensions. So we're going to take a slight detour. If we look at the depth charge and we look at the ship, what do these two have in common? What we just talked about, right? So in other languages, Python included, it has like an inheritance hierarchy. You can have, you know, a dog can inherit from an animal and it can have the traits of an animal. In Go, it doesn't have any of that inheritance hierarchy. But what it does have is it has composition. So we can compose our types of other types. And since we have a ship and a depth charge that we know we kind of have some of the same common types, we can have maybe a single type that will share that common data, and then we can just compose our children's structs with that common type. So we're going to call this an entity. And we'll have an entity. And since we decided that we need a location and some dimensions, we can add that onto our entity right here. And then our depth charge, we can just add an entity into it. There's a couple different things that we can do. This is like a property, but we could also make it like a top level property, and anything that's defined within that main entity we can actually access as if it were a component or a property of our depth charge. Who knows what the word refactoring means? Oh, you got this. No? All right. So we've got some properties defined over here, our ship X and our ship Y. But if we're going to use our entity to store that information for us, we can actually get rid of our ship X and our ship Y, and our ship width and our ship height. But that's going to break our code, right? Yeah. So what do we need to do to fix it? You got kind of a puzzled look on your face, and you got me concerned. You have any questions? Well, do you want to think out loud? No? Okay. There's a terminology that we sometimes use in developing, and it's called rubber ducking. And it's this idea that sometimes you just need something to, like, you just need to talk things out loud and talk through it. So if you have, like, some people actually have a rubber duck on their desk, and they'll use it as their debugging and their developing partner. So, okay, so we just got rid of the properties X and Y, or ship X, ship Y, and ship width and ship height. And we just got rid of it off of our constructor function here too. So do you think we're going to be able to compile our code? No. But we're using our entity over here to store this information. So let's create a new entity, and we will pass in and we're going to have it return a pointer because we want to be able to change and update these values and have it remembered. Okay, so we've got this entity that's now going to store some common data for us. It's going to store where we're located and our dimensions that we talked about. And then over here, we can just create a new entity on our ship. The only problem is now I can't remember what our values were. So let's just maybe 40 for X and Y, and then width, and then height, we'll say 75. So we've got a new way to reference our values, and we have that over here in our ship, but we need to actually be referencing them now. And so we can really just update our code with the properties that are now set on our entity type. It's tough because I do come from like a classic object-oriented programming world, and I want to say from our parent type, but technically it's not. So if I say it wrong, you guys can just call me out again and we'll fix it. X, Y, width, and then height. So we've now moved kind of some common functionality into our ship, and then we can now use on our depth charge as well. All right, so Aaliyah, you mentioned that we needed to know where the ship was when we fired a depth charge, right? So what parameters do you think needs to go into new depth charge when we create a new depth charge? We could pass an entity in, or we could have it create an entity. I think that might be more so a matter of preference, really. I think I kind of like the idea of just passing an X and a Y in and say, hey, this is where you're starting. Go ahead and kind of set yourself up from there, if that makes sense. So we can create a new depth charge, and we know that we have an entity as kind of the parent type. So we can pass in X and a Y, and now we can kind of guess what size we want this to be. Maybe we could start a depth charge just being something like 20 by 20. And now let's look over here. What do you guys remember when we talked about the game engine and the methods that it takes? Kind of a struct is a group of properties, and an interface is a group of functions or features, if you will. So on our ship, we have an update method that kind of mirrors this update method, and a draw method that updates that draw method. That's something that's going to be common throughout everything that we build, just because that's how the game engine runs, and it makes sense for us to hook our other components into that same way. So we'll have a depth charge, and we'll call update. And we'll have a depth charge, and we'll call a draw. Okay. Hopefully we'll start talking about errors more and more detail. But until we get to like loading images off the file system and can actually run into certain errors, it's easier to just say they exist, and we'll talk about them later. All right, so we have this kind of basic depth charge class. Do you guys remember how we got the ship to draw over here? Do you think we need to do that for our depth charge to draw as well? Perfect. So we will make sure we call field rect screen dc.x, dc.y, dc.width, dc.height. What color should we make our depth charge? You got this one. What color do you want it?
Purple.
Purple? Perfect. All right, so we'll have a purple depth charge. So, how's everybody feeling? There's a lot going on here, right? So we've created our struct to hold our data, and we've added some methods to it so that the game engine can call into it and say, hey, you can update, you can draw it now. Everybody feel pretty good about that so far? So we've had this request charge, and we know the ship's going to be calling that. Where are we going to store this depth chart so that the game can use it?
The depth charge file?
Okay, so that's our blueprint, right? But now we need to store like an object of it in the game. Yeah. So we've got a ship struct, and we're going to have a depth charge struct as well. So we can. So we know our ship is right there. And we can get our X and our Y for our depth charge. And we can create a new depth charge. So what do we need to do to get the depth charge to draw?
I mean, I don't want to.
I know. Does anybody think we're going to have any problems with this? I think we're going to have a problem. What problem do you think we're going to have? We'll run it. We'll find out. How's that sound?
I mean, it's not going to move.
Well, I think it's going to be even worse than that. We're probably going to crash our program.
Oh, if you keep pressing fire.
Well, so the challenge is that fire is a callback. So until our ship fires, the depth charge isn't created. And because the depth charge isn't created, we have an invalid memory address. So it's a no pointer. We just had a good no pointer exception. So we programmed it good, or well, sorry. Sometimes my English isn't. fg.depthCharge does not equal nil. Does the nil pointer exception make sense? No. So up here, we have this depth charge, and it's a pointer to somewhere in memory. And until we fire, we actually haven't created a depth charge. It's just a nil pointer is what they call it. So we have to fire before we actually have something for our depth charge to work off of. So really when we call draw or we call update on this depth charge and there's no memory there, it's like, hey, I can't do this for you. Can't help you. This is kind of what's going on.
So you put something there and you said this is what you're going to hold, but you didn't actually give it anything to hold yet.
Yeah.
So you try to
Yep.
do something with it. You can't.
It knows what's supposed to go there, but it just doesn't have anything there yet. So we're just making a check. We're saying, hey, if you're not nil, then draw. Meaning, if you have been initialized to something, then it's okay to go ahead and call the draw method on it because it exists. So hopefully, this time we can actually do something. So hit the fire button. Now what's wrong? It's not moving. Right. So what do we need to do to fix that? Yeah. Depth charge does not equal nil. Depth charge. Ooh. Sometimes your intelligent editor gets ahead of you. So we're going to call update. So let's look over here at our move method real quick. Let's see, right here. So we're kind of getting is move x. And then if we've decided that we can move and it's a valid move, then we're going to update our x. But what axis does x represent in our game? Remember, we got a little origin up here at the top left. So we got our x and our y. So do we want to move on x or do we want to move on y? Yes, yeah, we want to move on y. So we can add a speed, and we'll just call it gravity for now. So when we go ahead, we need to actually set a value. How fast do we want it? Do we want our gravity to work? How fast do you want our gravity to work? 7? 7? Okay. We'll have our gravity work at 7. So every call through this update, we are going to want to check and make sure that we can make this move. So we're going to have an x, or sorry, our y. See, I got caught up too. Move y. And we're going to have our y position, and then we're going to add our gravity to it. And right now we can just say, we'll just say our move y is just what we're going to move. Seven pretty fast. But now what's going on?
It restarts.
It restarts.
We only have one.
Yep, we only have one. We only have one depth charge. How many do we need? A lot more. Yeah, how many more do we need? So this is kind of what I wanted to get through to start talking about arrays or slices. I'm working on a blog post, but it's going to take me just a little bit longer to get it done to talk more about it. Does anybody have any questions before we move on? No? No? All right. So yes, we only have one right now. We only have this one depth charge, and every time I fired, it said, whoa, let's just create a new depth charge and we'll set it to the position where the ship is, and then we'll have that one go too. We actually want multiple depth charges. That was a simple change, right? Did you guys see what we did? What I did? So I just changed the variable name and called it depth charges, and then we put these square brackets as opposed to curly brackets. We put these square brackets here, and that's now saying that this is a slice of depth charges, or a list of depth charges, or an array of depth charges, kind of depending on how you want to think about it. So we can now, when we go to create a new depth charge, we can do what's called an append. This kind of goes back to Go's roots in C. The slice itself doesn't really have any methods on it, but append is a keyword of the language, and it will do what it says. It will append a new item onto a slice. So we can call this append, and now we've got this problem over here where we have the wrong name. What do you think we need to do to access all of our depth charges? So that's a good first step. But you asked about while loops last week, right? So what do you think we need for our slice or list of depth charges?
I need to make a list first, but did you already make it?
We declared it here.
Is that actually,
So the nice thing about Go is the default value of a slice is a nil value, and you can append to a nil value. So we don't even actually have to instantiate our slice, which I wish it worked the same way for maps when we talk about maps, so if that will come up, but we can just say, hey, this is where it is, and just append to it, and it will append to it for us.
so you need to tell it which one you're gonna work with?
Yep.
Which depth charge?
Yep, so we need to be able to work on every single one of our depth charges. And so we're gonna introduce a loop. This is probably telling us, you got an unused variable, declared and not used. So what do we need to do for each depth charge in our list of depth charges? What method are we working on right now?
Updated?
Yeah, we need to update. Oh. Somehow I turned my caps lock on. Depth charge update. Yep, so we'll update every depth charge in our array, our slice. And then what do we need to do for our drawing? Okay. Should we check it out? So we have an array of depth charges now. And as our array of depth charges is running through the update, it will update every single depth charge, and it will use the logic that we put here inside of the depth charge update to update itself. And then it will use the draw as well. And so now we have like this large list of things that are running and being processed for us, running inside of our game. I think I'm going to change the speed just a little bit. Just, maybe when we get to the point of having some simulated water, it'll go a little bit slower. We might even want it slower than that eventually. How's everybody feeling? Did we cover too much stuff? Do we want to talk specific syntax?
You want to go over the parts of the for loop? Because it probably looks a little different than
Yep,
Python.
for sure. I wish I could remember what a for loop in Python looked like, because they've got a lot of like list comprehensions and stuff. So there's a couple different ways that for loops work in Go. I'll write another one out here and then we'll kind of talk. If I can spell correctly. All right, so this is like an iteration type of loop. And then we'll call this a while loops cousin, if that works out all right. So we'll look at the while loops cousin first. You can specify a for loop and you can put any value that will equate to true or false into that loop, and it will run as long as it's true. So that's kind of our initial type. Our next type is the sentinel type, and you declare like a variable or the sentinel value. Do you understand what I mean when I say sentinel? It's kind of like the guard that's protecting when you can move on in the loop. So we have this sentinel value, and then this is where our condition, and this condition is much like this condition here. It's something that is going to be true, and if it is true, then it will continue the loop, and then if it returns false, then it will break out of the loop. And then this is just any updates that we want to do for the loop, and in this case, we're updating our variable I. So we can...
If you want to do the same thing you did in the for loop above, that loop.
Yeah, let's look at that. I'm gonna comment this one out because if I left it there, it would be a never-ending loop, and the game would just lock up right there. So right here, we're doing the iteration type of loop, and it works with this keyword range, and the range will just go over every single item for us. But if we wanted to, right here, this is going to do the same thing for us. What I'm trying to do here, okay. All right. So we'll run it, and what we'll see, hopefully we'll see that the same thing will happen, and then we'll also get like the for I, because that one's just running. Okay, so we've at least shown to ourselves that it's doing something. I like the range when you're working off of a slice just because it's a little bit simpler syntax. But this one, we're using the length keyword, and the length keyword will just give us the length of the depth charges. And then our sentinel value, we just initialize to 0, and then we'll just step through every one of them based upon an index into the slice. Does that feel all right? Is it?
What is that underscore in the for when you did it with the range? Is that...
Good question. We could pass, this is the index. So think of I here. This will pass the index and the element, and we're going to have access to the index. So if we needed to use the index, we could. But if we want to do this style, but we don't care about the index, you use an underscore, and it just says ignore this property. And then we can do that, and the compiler won't complain at us. But it's good when you're ranging over a map, which we haven't really talked about yet, because you can have the key and then the value and have access that way if you need it. All right, how's everybody feeling? We can ask questions. We can talk about one of the problems that we have with what we've put in for our depth charges so far. What do you guys feel? Because we have a problem.
Yeah.
What's our problem?
Well, I did torpedoes over the last week. I did a kind of different approach than you, but you're just putting stuff in your list where you're just going to fill up your list. I don't know if that's the problem you're talking about, but it's just going to grow
Yeah.
as long as your game's running because you're not getting rid of them.
Yep. So, yeah, exactly. Where we have our game window right here, that will fall forever. I mean, we can't see it because our window is not scrolling, and we could build a scroll window, but that's another discussion. So that is it's just falling still. And we do have the potential to run, I mean, there's no reason to do a collision detection on a depth charge that's, 10,000 pixels off the screen. So we could discuss that problem. So did you run into that problem? Was it a performance issue or?
Well, I just knew that I had to basically say, when is this thing off the screen?
Mm-hmm.
Delete it.
Yeah, yeah. So how did you decide to do that?
I think I did it in my update function, and I just, as part of the update, I calculated if it was, actually, how did I do it? I don't remember if it was in my game or in my,
And I don't think there's a wrong way to do it. I just more so just
yeah, I'm just,
conversation about what you've done.
I think I had a fire, I did it a little different. I had a fire update function, and then I think, yeah, when I updated after I fired, I would basically run, after I updated all the positions, I would run, basically, I would make another list of stuff that was off screen and then get rid of it.
Mm-hmm. Yeah, that's not a bad way to go. I propose we add another property onto our entity. And we'll call it, well, we'll call it isActive. So we'll have this other property, and now on our depth charge, we've updated. So we've just updated our Y position. And if we want to be able to determine if the depth charge is still active, what do we need to know?
It's bigger than our screen height. Or
Yeah.
Y position is farther than our screen height.
Is greater than screen height. We will say is active false. So we'll just say, hey, this is no longer active. Don't do something. So now what we need to do is we need to handle the case where it is no longer active. And there's a couple ways that we could do this. I wish I could say this is the perfect and right way to handle this. That's why I asked your question of how you handled it, just because there's a lot of different ways. But we could have, after our check for collisions, we could then run through everything and say, okay, are you still active? After we've done all of our updates, we're going to ask everything. So we are kind of looping through things a couple times. There's a couple ways that I don't think we're going to run into massive performance issues if we just do a second loop, but we could check here and we say, hey, are you still active? But the challenge with that right now is we're actively iterating on this this instance of our slice. So if we start pulling things off out here, we're going to start causing problems potentially. So I'm just going to run here. I'm trying to decide how to do this because we're going to run into the same problem if we do another array. Yeah. Well, and you could create a new list and put all of them in the ones you want to keep, and then just ignore the ones that are no longer active.
Yeah, I just assigned that as my new list, or basically said now you're equal to this list. But I don't know if I needed to delete. I don't know if you actually have to do stuff. Not pointing to it.
No, it is garbage collected. And so if the reference that if the only reference to the depth charge is inside of the slice, and you change the slice, it will. Okay, so let's do this. Oh, if I can type. active. And then we can say, so something more like that.
Yeah.
We have a list that we're going to keep of our depth charges. And if our depth charge is going beyond the screen, we're no longer going to keep it. If it is, we'll keep it, and then we'll just set that.
The other thing I did is I assigned it an initial size that was as big as my current one. I don't know if that's a performance enhancer or because that's coming from C++.
Yeah, we could. I mean, we could set an initial size, and I don't know if I'm as concerned with performance at this point, but yeah, it's probably a good habit to have. Okay, was that all just gibberish? Was that all just gibberish? So let's So we're just going to put a log statement in, and we'll kind of track and see how large our slice of depth charges is.
Did I miss? You didn't actually have a function that will tell it when it's no longer active, did you?
So yeah, so we said is active on our entity, and then here inside of our update.
Oh,
Yeah, so I'm trying to keep the logic for everything in its own place, and then that way it's like,
I just forgot you did.
yeah, no worries. So now we see that our depth charge slice has nothing in it. We still have nothing in it. Our function's not working, and I know why. Do you guys know why? It's because I didn't set it to be active.
It starts falling.
Little gotchas. There we go. So we're seeing our length is updating as they fall off the screen. And that way they're how do I want to say that? They're gotten rid of? They're getting gotten rid of as they go. And so now we're not updating anymore. And then when we do collision detection, because the most expensive thing computationally is going to be the collision detection. So yeah, it's really good to clear up our arrays or slices of things. All right, questions. I think this would be a good time to just cover more questions. Do we want to talk just general syntax? I want to make sure that you're feeling all right when we leave class today. And I can tell you're kind of like, there's a lot going on here. And that's perfectly fine because we've covered a lot. Currently but 4. Let's see, and then rename. Okay. All right. trying to think what to talk about.
For that append function,
Mhm.
I had to look some of this stuff up, and so one of the things that was kind of weird to me is like that first parameter in the append is you're passing yourself, or not yourself, but you're passing your current array back into the append again. That could
Yes.
also be used to add to totally different arrays.
You could. Yes. And you can also like append two arrays together with it as well, or two slices. This is one of those built-ins. So when Go was created, they didn't have any generics. So this actually did like a lot of compiler intensive things for the append. And so I think it's kind of going to stick around that way because there's another function called make that we'll see for maps.
I used it to make a slice, but I guess I didn't need to.
Yeah, you can, and like the little trick of, oh man, I can use a nil reference of a slice to append things onto. It took me quite a while of Go development to figure that one out. How's everything going?
I don't know, you have to look at her because
How's everything going?
Good.
You feeling good about the game development stuff? You had a chance to look at blog posts and videos, or yeah? All right. Well, do you two have any questions? No questions. All right. I'm just kind of thinking through what would be a good thing to discuss at this point. Because our submarines are going to work much like our depth charges, and our torpedoes are going to work much like our depth charges as well. Who likes graphic design? You do? You do? So I'm a Linux user. We kind of discussed it a little bit. I don't know anything about like the Adobe Design Suite, but I can at least wrestle my way around Inkscape. But I'm more of like the classical engineer who's not great at graphics. So let's change our color here. Actually, let's go black. So we've got our game window. Oh, I was hoping that was going to be like a pencil. Just a second. That was kind of weird. I really do need to bring a mouse to do this, don't I? So here's our game window. And we're going to have like a sea level right here. And then we want all this below to be blue because it's going to be our sea, right? So we have a height that we've specified for our game. So let's go back over here and look at what we have for our game real quick. Our height we specified is 1280. And our ship, we've told it to start at 100. And it's 75 pixels high. So if we do, who wants to do math for me? I don't know, I hate doing math in public. So if we do our 1280, and we're gonna subtract, yeah, you're right. So we're gonna do our 720. You're right. So we've got our 720, and then we wanna subtract our ship's starting point, which is 100. So we've got 620. And then we want to come down maybe 3/4 of the way of the ship. So we want it to be 580. Should we say 580? I'm just guessing. I need somebody to do the math. So our width is 1280. And then our height, we're going to say 580. Okay. And then we need, okay, so for our people who said they like graphics, what's alpha on an image?
Is that your transparency?
Yeah, that is our transparency. I wish that we could set it here, but the game engine doesn't. The game engine doesn't let us run pings at this point.
That you run what?
A ping, a PNG.
Oh.
Pings have an alpha channel, but JPEGs do not. All right, so we've got a little square here. Doing some of this stuff off the cuff probably wasn't a good idea because I don't do it very often. Okay, so we're going to set a little gradient here. Does that look like water? Close enough? All right, so let's save. And we'll go to our game directory. And we're going to create a new directory here. I'm just going to call it raw, as in like our raw assets. And we will output this. I think this was not what we want to do. So I'm just thinking about, because if we don't, well, we'll try it. I'm thinking too far ahead of myself. So we have our SVG, and then we're going to export. Let's go back to our games directory, submarine game, assets. All right, so we'll output this ocean. And now, hopefully, we have an asset over here, which is an ocean ping. Okay. We need an image for ocean. I don't know if what I want to call it. So we got an image here. Okay. So we've got our game directory. We've got an assets directory inside of there, and we have an ocean.ping that we just created. And we need to be able to open that. I have to remember off the cuff how to do that. Let's see. Image dot decode, I think. PNG. We might have problems because I said we couldn't do the ping. That takes a reader. Okay. engine error. Oh, yeah, I gotta remember this returns 3 values. Sorry, I'm kind of quietly going through this. We'll talk about it in a second. Subgame dot ocean image dot new image from image. All right, so we just did a whole lot right there. We created our ocean image, and it's residing on our file system right now. And we need to be able to actually read that image off of the file system and get it into the memory of our game in a way that we can use it. So this os.open is the call that says, hey, open this file, and it returns what's called a reader and an error. The reader is just an interface that has a read method on it, and it knows how to read data off the file system. Once we get our reader, we can pass it into our image decode, and the decode call is what takes the raw data of a PNG or a JPEG and turns it in, like decompresses it and turns it into an image that can be displayed. And then this eb10.newImageFromImage is what turns it into something that our game engine knows how to display. And right here, we're just, if the file system can't find a file, it will return an error, and then we'll just crash the program ourselves. Say, hey, we couldn't find it, just die. And if we can't decode it, so maybe it's not a PNG or a JPEG, then we'll just die, and it will give us an error. So that's kind of what's going on here. And then inside of our draw, we're drawing this background, but we probably want to draw our image on top of our things, right? So like our depth charges will kind of go behind the water. Does that make sense? But we also want to be able to see them. I gotta remember what this is called. Okay, ops dot alpha. I wasn't sure if we were going to get here today, so I'm not exactly prepared to remember what this is called. Point. And then, so how tall do we make our water? 580? So what's 720 minus 580? I can't do math I struggle doing math when it's like I'm standing here and working in front of people. Oh, wrong one. .gom.translate. So we want x to be 0, y to be 140, and then screen.draw g.ocean ops. We're just gonna do a Hail Mary and see if this actually runs. Holy cow. Holy cow, that worked. That was like, so we're kind of running through, you can see like the water line on our ship, and our depth charge is sort of kind of running. It could be running behind or in front, we wouldn't know, but with our ship we can kind of tell the difference, that it's, you know, sitting and bobbing in the water. So we just went through something I wasn't for sure we were going to cover today, but I think it's good that we've got it done. So we've got, like we talked about, we created an image in Inkscape. We pulled it into our game, put it in a way that the game engine knows how to talk, or not talk about it, but how to use it. And then our draw, so we've got this draw image options. We needed to change the alpha so that it was kind of transparent or semi-transparent, and we needed to change where it was positioned in the game. And so that's what's happening here. The scale alpha and translate is what's doing those two things for us. And then we can pass those options to the draw image call, and then it will update them accordingly. Any questions about that?
Well, not about that necessarily, but I was just wondering if is the ship going to be in the water or is it going to be under the water? Is it the submarine or is it the ship?
This is the ship. The submarines will then be down lower in the water. And you know, if we look at this real quick, just like we drew our water image, we can actually draw a ship image, and we can put it there instead of our orange rectangle. And it will be like this. It'll kind of be in the water, you know, things get heavier and the buoyancy kind of takes over. It kind of bobs in the water. That's what our ship will be doing right there. And now we know how to draw an image. Okay, it was a super simple image. We know how to draw one, and we know how to pull it into the game, and I think that gives us a good place to kind of start seeing some other graphics.
If you do make the background transparent, then you draw it transparent also, or what were you saying?
I'm not sure that I should have tested this one better before we came. So I just changed the scale alpha, and it might still work for us. Yeah, it did. So it did recognize a pink, so we didn't actually have to do the alpha.
So that actually blended with the background too, because it's lighter before, right? That's why.
Yeah. Yeah, and so when it's the solid color down at the bottom, so we may still want an alpha so that we can still see down in the depths.
What did that? I didn't quite follow that translate the obscure.
So it's matrix math. Don't ask me to help. I don't exactly understand. But basically the translate is saying we want to reposition. So it will draw at the 0, 0. Like when we call over here on this draw field rect, we're giving it an X and a Y that we want to draw at. This translate method is what tells an image, hey, you're supposed to be drawn in this different location. Any questions?
When you opened the file, you don't have to tell it like what mode you're opening it in. I guess that's whatever you handed off to.
Yeah, this open call specifically doesn't, because it just opens it for reading.
Oh, it's a read.
Opens the named file for reading. If we were opening it, and there's another call, it's like os.open file. This open file will take the permissions, so if you want to write to it or truncate or something like that. But what we're going to be moving towards is there's an embed package or an embed package in Go that lets you embed all of your assets, and then they're read-only at that point. And that's what we're going to be moving towards, because I have a library that we're going to pull in.
So the game's all one.
Yeah, so you can just hand just one file to people and they'll be able to run it. Or if you want to upload it to the web, you can upload that one file. Yeah. This is the first time we've seen assets. Maybe we'll cover it next week, like actually embedding them and using the embed function, and then it really, once you use the embed function, it's just a go build, and it will compile it all in for you. All right, I think that's all that I have for today, unless there's more questions.
Will they have to, so if you package it up, do they have to have the Go engine on there, or is it run it?
No, it will compile it to, it will compile it to whatever platform you run on. You can cross compile, but I'm on Linux, I can compile it, and then I can hand it to anybody that has Linux, and they'll be able to run it. They don't need the Go tool chain at all. It will compile it to a native system. On Windows, it'll compile it to a native Windows executable, and on Mac, it will compile it to a native Mac executable.
The go-to code tool chain you get already have cross-compile, or do you have to set
It does, yeah. So I can't remember off the top of my head what it actually looks like, but there's a couple environment variables that you have to set before you compile. I call it's the Goose. It's GOOS or GoOS. And then Goose and GoArch. And you have to specify if you want like x86 or ARM. And then you can just run that and compile it. And as long as you're not using CGO, it will do it. But we are using CGO because, and if this is just food for thought for you, I know we're talking gibberish. There's another tool called Zig, which is a new programming language that has all of the architectures and all of the operating systems C source in it. And then you can use Zig as the compiler for the C components, and then it is truly cross-platform. But that's way beyond the scope of what we can really cover here. But it's interesting to know because it does do cross-compile really well. Any other questions? All right, well then I will work on pushing this code up and making it available. And I guess we can, have a good evening, I guess.